So platinum is a material typically used in catalytic converters. To reduce materials costs, nickel is incorporated. What is the unit cell edge length for an alloy of 20 weight percent nickel and balance of platinum? Both nickel and platinum have face-centered cubic FCC crystal structures. And we're given that the density of nickel is 8.91 grams per milliliter, and its molar mass is 58.69 grams per mole. Platinum has a density of 21.45 grams per milliliter, and its molar mass is 195.08 grams per mole. So the first step that we need to do is we need to determine the relationship between density, if we're given the crystal structure, molar mass, and volume of the unit cell. And we see that in this relationship here, in which density in grams per milliliter or grams per cubic centimeters is equal to the number of atoms in a unit cell times the average molar mass divided by the quantity of the volume of the unit cell times Avogadro's number. And so we must calculate for the average molar mass as well as the volume of the unit cell. And so we can rearrange this equation in which we want to calculate the volume of the unit cell, which is related to the cube of the unit cell edge length, and that is equal to the number of atoms in a unit cell n times the average molar mass of the alloy divided by the average density times Avogadro's number. So, in order to calculate the average density, we can use this relationship in which the average density is 100 divided by the weight percent of component 1, or nickel, divided by the density of component 1, which is nickel, plus the weight percent of platinum divided by the density of platinum. And we can compute that to be 16.74 grams per cubic centimeters. And the average molar mass of this alloy is just the weight percent of nickel divided by the molar mass of nickel plus the weight percent of platinum divided by the molar mass of platinum. And that is equal to 133.18 grams per mole. And thus, the volume of the unit cell, which is the cube of A being the unit cell edge length, is equal to N, where N is the number of atoms in a unit cell, and there are 4 atoms in an FCC unit cell, times the average molar mass divided by the average density that we just calculated times Avogadro's number. But we can see here that this has units of centimeters cubed, and thus a cube is equal to 5.28 times 10 to the negative 23rd centimeters cubed. This is an extremely small number and not how we conventionally display units for unit cell edge length. And so we could convert this to nanometers by first taking the cube root to get A is equal to 3.75 times 10 to the negative 8 centimeters. And we can convert from centimeters to meters. And we know that there is 10 to the 9 nanometers. In 1 meter to get 0.375 nanometers or 3.75 angstroms. So let's check. If our unit cell edge length is 0.375 nanometers and the blast burn for nickel is 3.52 angstroms, and platinum's unit cell edge length is 3.92 angstrom, we can see that 3.75 angstrom is somewhere in between that, and that makes sense.